Hello guys, welcome back to another video of Daily Hacks. Today this video is a little bit, tonight, this video is gonna be a little bit weird. I'm gonna design some PCB and I'm gonna put my very own video on my YouTube. I've never do this before, mostly when I'm working on PCB, like designing, making a schematic on PCB, I oftenly doing off camera because I want to be like I want to hide my mistake about how I do the board, laying out the wires, hole and things and stuff. But today I think I'm brave enough to, because I've been working on one project for a couple of days now. This project, as you can see right here on the screen, of VFDHack32. The main idea is the display from VFD display that I got from 6 years ago finally working. Sort of, except for the grayscale that I'm working on, really painful. Anyway, so actually first I write the code in STM8, my controller. It turns out that guy is running too slow, so I just moved to STM32. And I think it's a bit, it's not a bit, it's a whole lot faster. And right now I have the code that is working really nice. Is in the condition I think that I can make the dedicated what's called daughter board, maybe to plug into the main module. I'm gonna show you a little bit on the main module. So it looks like this. I'm not sure what it looks like. Let's see the light is, this thing. So this is my 32-bit microcontroller. STM32 F303 Discovery board. I call it F303 Disco. And this thing is quite powerful. Cortex M3. It's got about the memory, I'm not sure, but it's a lot. I got this thing for about 750, right around 20 bucks, which is really reasonable for the very powerful microcontroller depth. And this is a VFD module. Let me unplug this for you. Really powerful. Okay, so this is the module itself. I actually put some kind of filter. It's a blue filter. It's not actually blue filter. It's just random plastic that I taken from battery replacement, and they have some kind of packaging, and it came with this nicey blue sticker, so I just put on the display itself. So this is the module itself. On the back there's a pin headers right here. One of the pin headers ripped off. Gonna fix that later. Got pin header, got a voltage regulator, the 50-volt boost. It's actually about 30 to 40 volt, but it's fine. Here is the STM8S microcontroller generating a 200 kHz PWM 50% duty cycle, and some kind of the chip that I cannot remember the part number, LM4871. This is some kind of op-amp something speaker driver, but they have one that reliable, that's designed to, not designed, but it's just like a rebadge chip for driving the filament of this type of VFD display. So just find a better one like this one. It's just rebadge IC, so you think it's the same, so why go something really hard to find? So anyway, I think I'm gonna show you a little bit of demonstration, but on that I probably need to hammer this thing. The pin is loose again. I think this is the second time, because this 5x2 connector is really tight. Yeah, show you. And let me untop my welcome rip off. Yep, this thing still works. Let me show you that. Found is it turbo camera? I think you can see it a little bit. It's not focusing. Yeah, this is really nice. VFD display. Although they have some little blur mark that I am really stupid shining laser into them 2-3 years ago. I just playing laser and I thought this display is dead, I'm gonna do something fun. But it turns out that it's still working well. So yeah, really nice module. Except that there's a flaw in the design of this thing, because the inductor, I'm not sure you can see here, inductor really hot. I mean, it can burn your finger. Some kind of maybe the current is too much. It's burning, not burning, it's heating up really seriously. But anyways, I'm gonna find some kind of like a cooling solution, probably just put the thermal pad and some heating on it. I think this thing is just fine if cooling is great. So anyway, let's start with the, before we're gonna make PCB, I'm gonna, this thing is ready. Before making a PCB, we're gonna take a look at the IDE of STM32, the STM32 Cube IDE, and take a look at the project file a little bit. There's a hardware setting that we need to use that because there's a pinout that defined in the code. So let's switch to, let me switch to this thing real quick. Okay, so this VFDHack32 is the original code running on S3 Discovery, except for this one. And this one is specifically ported to the daughterboard variant that I'm going to design tonight. And the microcontroller that I'm gonna use is STM32F3 F030 P6, and this is a little tiny TTS sub 20. It's just 20 pin. It is really easy to solder, and everything I'm doing, you don't know with me. This is not scripted, so I'm gonna start it right now. So I'm gonna make new project file. Just like right click new project file. I'm gonna call it. I already have this PCB board for that display module. I call it the GU 154 by 39 LOL. Just like name scheme similar to Naruto game. Anyway, so let's rename the project. So we're gonna call it VFDHack32 daughterboards, just for DB. Oops. VFDHack powerboard. Powerboard is just like a concept to power things up, but yeah, I got working modules that need to do. So let's turn the grid on. Let me go to the part list first. So take a look. Close these windows. Let's see, OBS still running. Yeah, still running just fine. I need to take a look at the pinout this thing too, because like this part, how they connect. So I don't even have the library for the microcontroller yet. Okay, So we're done with this. Let's move to the what is called device. I'm gonna add the part here, symbol. I think we're done. Let's go to here. Let me import the library. Return the great one first. The library, open library manager. Library. Scroll down to the thing. Here it is. And use, move in views. Okay, so let's put some of the parts. First, go down to opacity to never mind. Okay, so got my control and stuff, and then I'm gonna go with the control header. Should be 2x5. If I don't have them, we're gonna go with like 1x5 with two of them. Okay, 2x5. Exactly the same that I used before. Previously used. And I need some kind of connector. So we're gonna provide 5V and ground, and then two wires up. As you can see. So we can need 1x8 of it doesn't have kind of be locking like this one. This one. Top one. Anyway, I'm gonna go with this one. It's gonna be good wires. I think I can implement something else, or maybe I'm gonna link some kind of GPIO. Suppose 5V and ground, got 2 of them, and then my capacity is 2 of them. So total is 4. There's no need to interrupt thinkies. I might add some kind of GPIO, but use one of them, and by using that later on. So I'm gonna go. It's 2 meters. I'm gonna go with this one. So I'm gonna expose one of the GPIO for later use. And we need connector like name. Gonna be header. We need some kind of master. I think I'm gonna take a look here. Maybe they have some kind of fighting, like electrical design. ADC. Let me take a look at index. So characteristic and input. Power supply scheme. Oh, let's take a look at this. Fair plus the Michael Fair. I can use ADC. Like, yeah, I think it's the nano 100 micro. Oh, like I have multiple this, and use like I have the micro and the microfarad range like 2.2 and 1 microfarad. I have the 0603. 9, 2, 3. Keep 3 of these. You see, because I have the larger capacitor than 100 nanofarad. Let me take a look at my schematic of this thing. This one is 100 nanofarad. 100 nanofarad capacitor. This one. Let me use the info. This is 1206. So here I use 1206. I'm so backward thinky stuff. OBS still alive. So I'm gonna name this value 1 microfarad. Let's see what we got for 200 nanofarad. 4.7. I don't have 4.7. I think 2.2 gonna do the job. How do I? Oh, that's what I thought. Yeah, I think that is enough. 3.2. We got something I cannot really remember. Anyway, gonna go like 2.2. Gonna get the number. And then the 100 nanofarad. Gonna go with super 12.6. 12.6. Oh, 6. That one use 12.6. It's gonna be 2 of them for the VDD, 1 of them instead of Arduino for the VDDA. Just swapping this thing around. Why don't just buy? Get rid of this. Assign how you want this. And fair. Let me just copy this one. Okay, so I'm gonna grab the supply. So there's gonna be 5 volts high and 3 volts high. 5.5 and 5.3. You can use different one. But this one is 3 volts. And this one is 5 volts. I don't think this is the same. Let me like wiring up some of these. Yeah, I haven't like let's see if this thing is actually separate, because the nodes may be different parts. Maybe one supply library, supply would like another side of the wall. Let's move this in. Okay, it's separated. Good, good. So let me move one of these. This one needs to be really close to the controller, but this is just schematic, so there's no worry here. Okay, 3 capacitor. Just connect them in parallel. This one is gonna be ground. Yes, totally forgot ground. What? Paste all the ones. Not create schematic yet. Let's update all this. So brown here, gonna put right here. Move this thing all the way. This brown. This gonna be our 3.3 volt line. Oopsie. Volt line. One thing that I want to do is the bus. That I haven't used that yet. Like wiring things, and like you turn it to the bus, so you don't need to wiring around individually like this. One is here, one is here, 1 microfarad. I'm gonna give him also 2 microfarad, 2.2. It's microfarad, probably. Yes, microfarad. And brown one. It's brown. In the code, I actually use the external clock, but let's see if we can use internal. Run 48 megahertz. I use the keyboard. It's a good. I don't need to use external crystal, though timing might not be good, but I think it's good enough. I never found any issue running without the external crystal. I'm not sure about boot 0. I'm gonna make some kind of jumper, or maybe it's gonna be swish, because I have the dip swish, and I also have that Eagle library, which is my own too. I'm not sure about the relation of this. Take a look at the why stopping forward backward. Also because maybe they have falling ground. Okay. The reset pin, we need to pull it up. Resistor, we need 3 of them. 2 is for I2C. I'm not sure which part. I just ordered that part. Let me check a little bit on AliExpress. 4.7K resistor for specifically for I2C boot up. Okay, it's 6.3. But that is beautiful. Yeah, 6.3. This is 2 of them. One is for reset. One of them. Also, I need 1 capacitor. It should be like 10 microfarad. I'm not even sure how to design reset. First thing. Sterling. Actually connect. I've got pull up 47K. Great. I have 47K already. 1 nanofarad. 0.1 micro. Okay, I don't know. I'm gonna use I'm gonna use 100 nanofarad again. We're using this guy. Down below. And for next, then to reset, this part is ground, and this one is go to VCC everything. VCC, I mean VCC of 3 volts. And then I need a test pad. Test pad is especially for programming. I always go with something like this. I got one for reset, and one is for the swim, I believe, like how interface to the swim interface. Be like 0 and PA1. Like how we use debug here. It's the BOC, okay, and the BOC. Okay, so PA 14 and 13. Gonna 1 is for reset, and 2 is gonna be for that debugging. That is useful for programming. The upper is will be okay. Will be on. Need to put the name. It's only for that to use programming feature, like I want to program with this tooling. Do I require that pin or something else? Like we got PA equals 14, not a PB, PA 14, PA 13. What is it? Yeah, the BOD function properly reset. Two of that pin this pin is actually for programming. This one is gonna be for reset. Next, gonna wire up something. No, before that, it's 15. So we need voltage regulator. So we take in 5 volts. We take in 5 volts and we output 3 volts. Copy this. And we share the same ground. Carry on the OSHPark. I'm gonna let the first pin for power. And last pin is And then there's gonna be boot up receiver. This one I'm not sure it's for probably 5 volts, then 3 5, but it is quite challenging designing the I2C bus because now it's got different voltages like 3.3, you got 5 volt, you got 3.3, you even got some weird thing like 1 volt. Need to decide about the food at 6. This one is 4.7, so this one too 4%. Make sure it's still recording. Nice. 52 minutes already. Is I don't think that I'm gonna use this daughterboard with 5 volt device. I'm gonna try 2-3 volts. Because most of my controller that I'm gonna use with is gonna be some powerful controller, and those are running 3.3 volts, like STM32. Schematic as processor, 2.3 volts. I'm not gonna use this with Arduino AVR, but that is 5 volt platform, not using that. And then gonna wire this thing. This last bit is going to be the user item. I'm gonna call it user item. So even in this one, PA9 is well, that's the L, the A. Great. Next, let me do about the thing that I can remember is in 9 spot volt in 1 is around 2, 4, 6 is data pin. But since we don't use PWM, I plan to make that to use a PWM feature to make grayscale, but it's really hard. Maybe I'm gonna do hardware implementation. So there is no 0 input here that you see is my number 1, number 2. I'm gonna join them together since we're not using this GCP. It's gonna be joined together. It's gonna connect to the SPI master out slave in P07 like this. Don't forget to save file. The SPI clock. The clock will connect to this. We'll see. Is connect to PA5. As I said earlier, pin 8 is flat. Okay. Oh no, pin 8 is easy. Pin left them open. Pin number 3 is cleaner. Cleaner needs to be tied to VCC. Actually implement the shutdown. I think I'm gonna hook this thing up to some of the code. Maybe we're gonna implement the feature. Do it support 3.2. So this display is never sleep. Okay, I'm gonna implement one of them. Like cleaner. Gonna call cleaner is filament enable. So enable. Let's mark this thing. This one is mosaic massive isolate. This one is top feature. We don't need to be too important thing. One is lat, another one is blank. This one is blank and blank is PA2. PA2 you will try. I think the lat connected it. Okay, so we should float the GCP. Alright, I think let me check it again. The first thing is ground, and we start with it's right. Okay, we're done. I think we're done. Let's take it a little bit further more. Reset is fine. We not get the 3 volt yet. Whoops. One here. And move this one. Let me check that again. We got the OSHPark. I think it should go to somewhere else. That is real terrible. Use that copy. I'm gonna use move. And come up, input style, and here output image. Okay, we're done. I think I'm gonna add the another important part. It is not sure that thing is gone. It is thing is yeah, open source hardware. This thing is quite open source hardware. Use. I'm gonna add the source hardware. Logo. We get the smallest one. Yep. Gonna add some description. The 32 hack. The GJ or the other board. This time. No. Big thing. Island. Budget. And 154.39A. Symbol. Name. I'm gonna use that. Okay, we create. Oh no. go to back. Liquid. My mouse. Yes. Liquid on. Every time when I design this PCB, first thing I keep in mind is make it small as much as possible because it's gonna be cheaper. Okay, so I'm gonna move the biggest part with these connectors. Let me zoom in the connector a little bit to make sure the pin out is correct. Because there's gonna be let me switch to my view. So this is the display module itself, and if you take a look back, there's gonna be a pin header. So I'm gonna need some kind of 2x5 female pin header to plug the like this on the back. It's gonna be, you know, similar to the board that you plug into the 16x2 LCD display module, but what is just my custom board. What time is 11 p.m. So I'm gonna put folders like here. Never mind of this. I've never got something from that. Let me make this thing align. This one is 600. Make this thing align with the frame. Okay. As you can see, this board is quite hard. If I put everything and just do like really few persons, I need to do it smart. So like moving things around. Designing board is really hard. I still remember like really first time when I designed a board. I actually use all the router, so we just connect all the pin, connect all the things together for me automatically. But that thing is really bad. It's going this way. Just got this motor. Right around here. Let's switch to this. This is standard. Some of the thing is gonna be gone, but that is good. So have more clear view of this. Moved in the regulator. I actually want to have more space for the microcontroller underneath it too, because I want to put those capacitor as close as possible to the pin. So let me move most of those over. The open saw thing just gonna left. Big boy, another big boy. Got some kind of pad here. Put them aside. Restart. Schematic. C1, 3, and 4 need to be both BD. So where is gonna put it on C1, C3, and 4. I'm gonna move most of these closer together. Make sure it's recording. Flip the board and C4, C2, number 1. Before going in, I think I'm gonna change the font size to 16. I'm not I normally use 24, 16. I think it's 16. Yeah, the thing is crazy small. It's gonna be 24. Okay, 24. Let's move things inside the board code. And zoom on that. Oh, if we got like VCC here. Like this. Or maybe rotating this guy upward. To make this thing crazy precise, 12.5 is way too too close to 20. And then the big boy here. Okay, I'm gonna save this. Going back, the VDD side we have C from C2, C5, C6, C number 2. Gonna move this thing closer. We got a really big one. I think we can move this a little bit more. I think we still have space around here to route. Need to take a look. Like, where is the food? This side is where it have ground. It's about hour-ish now. .3 down. This thing is really tight. One a little bit further more. Let me do some simple routing. What is this? Where is this thing here? button. I'm gonna go some thick wire. 3.3 volt is here. Not sure it's coincident or not. There must be something to explain this. Yeah, worry about that. I will order the PCB from OSHPark. OSHPark. Anyway, there does not have silk screen over the wires, whatever you want. And ground together. No. Ground together. Ground there. This firewall is just so close. I'm gonna wire that one up. The firewall is gonna be really thick one. We got ground things. Just like this 3.2 volts. Good. This thing a little bit tinier. I mean, a lot tinier. It's really bad practice that you put a via hole on the some of the board manufacturer might cover the via hole with silk screen, so it can interfere with the pad size, like the shape of the soldering pad. We need to make it. Got 3.3 here. But when we get brown, this thing is really tough. Okay. Since this is almost midnight now, I need to do a video. If we're going back here at the so I totally forgot to load the design rule from OSHPark. The VSO is much smaller, really nice. Going on here on my phone, nothing. SDA, we got user I really close here, so I'm gonna wire that thing up. So first, yeah, user I round. We got more time myself. This one I'm gonna go on top routing. Ground. See how pin is this. I'm gonna wire that first. One, two. So we step in right here. I need to be really careful about defining this. Going to here, right here, then using a VSO to connect to this one. This is quite challenging. this the first one. Yeah, that probably better. Mm, now why this thing this ground too? So this thing could be bigger ground point. I would use bigger point. Now I'm gonna connect this ground. So route through here. Gonna add the add a VS hole. Bottom to the top. Connect to that route. Also there is that route too. So I'm gonna use lower layer. I'm gonna use upper layer. I'm gonna use upper layer. And if we can route some of the signal like planar. Planar, if we can route the signal with really small, man, that thing is really big. Planar signal. It is so close to the pack. I don't want to do that. If there is another way around, wrong and pretty easily. Cleanup is quite hard to deal with. Let me use this thing. This is for preview. Yeah, this is on the bottom side. Let me zoom in this thing. This is on the bottom. All the text thingy I'm gonna move it later. This on the top side. He just pause this. But I think it will be fine. I think it will be fine. Got the NS6, S5. Everything is this signal. It's also crossing. Like and this one gonna be route through somewhere else. Right there's still some of the space left in the top. Going on 5 volt risk breaking the display if something went wrong. This thing is absolutely dangerous. I never thought that before. So this side is wired up. Now it's gonna be the SDK thing. Go straight here. I think I'm gonna take some kind of short film break this ground we can use in the top layer. And then this SQL thing will come from here. Like that. And take over the clears hole. And then this pivot where else. Save. Okay. I think this is nice. Still not connected. Right, 5 volts. Still got some of the pads. Capacitor, resistor, pull up resistor too. Pull up could be on this side. So the pull up is R number 1 and number 2. Yes. On the backs. It's way for the SDF bingo. SDF there. There's gonna be some current faster, then we're gonna increase the side. And VCC 3 volts. We are totally on a different side of the 3 volts. That makes it a little bit weird. So 3 volt, where can I access 3 volt? Because like ground is around us. Right, the ground is all around us. It's not good, but Oh, gonna route through this. Yep. This is going around. Maybe if you use this 3.2 volts, this use a PS hole going to this. So somewhere else. Here, we come up here though, and yes, still got some resistor lying around. This resistor is for reset. Reset from some of the pods. I think we should flip to this side. Gonna use layer set of top. It's gonna make it easier. Got lots of stuff in the video. Let me get them there. This one is ground, this one is VCC. This for reset pin. This one goes the SWDIO thing stuff. Checking the size of the text first before. Keep it clean. Effective. Properties. Yeah, let's just use like 1 hour, half. This is it. I'm gonna put it down here. So we're gonna have some space left for comment. Yes. So close to each other. We get close to really small. Let's use the okay. That's the blue here. Oh, that's the blue. Reset pod. This pod is too big. Let me change the UI. Increase Schematic palette. Indicators around. But I'm gonna use this one. Replace with this one. Hopefully that is replaced. Yeah, a little bit smaller, easier to work with. Big, big. Let's wire up the debugging for the width is 2 months. Yes, perfect. Still got the reset thing. Try to put this big past poster. So you can actually route the signal. This just looks stupid. Looks stupid around the clock. Why the trace line of clock is really long. I have a bad feeling about that. Here's that is a reset point. I think we should have the pull-up resistor tool. It's right there. And pull-up resistor. Somewhere else. This one. Yeah, a lot of stuff underneath. And then we have place to put change the font size to something small. We put resistor right here, like this, and there's going to be a pull up for that one. Like this, the OVC thing, I'm gonna use VS hole connect to the nearest PVC. I'm gonna move this a little bit more. Okay. We haven't connected pipe yet. It's really complicated. This or not literally no place to put the open source hardware load. This could be here, this could be here, but yeah, this board is too tight. I don't want to do this, but maybe we need to get on this. No open source logo. So we need 5 volts. We need to find a way to connect 5 volts. If we use that. Yeah, we got 5 volts. Then we still need to do the ground with this, like the nearest ground. This doesn't need to be a big. Ground here. Here. Bedroom. Little pad. This little top is gonna be just right here. Move this a little bit. Move this a little bit further. It's not a big problem. And the reset. That is a mess. Let's use the VR3. You can see a lot of stuff. Clearance. Gonna fix that. Okay. How approve. That's not big. Oh yeah. That's might be big problem on some manufacturer, but with OSHPark, no problem. Wire stop. Okay, we still got the wire stop left. We got okay, we're done. Most of it. I mean, routing is done. There's still more tasks to do. And this one. We've got some space left here. I start to put my contact. Design in Thailand. In the tank. Layer is gonna be top name. If top the font is gonna be a little smaller one. Then put the side and VFDHack32 bigger font. Let's use some kind of vector font. It's kind of cool. And gonna do some kind of draw the lines. Yeah, it's the space left here. Maybe if I can put that thing back, the open source hardware, maybe later. Gonna deal with the font. Gonna use preset. First, gonna use preset like top. Gonna spot some of the font if it's too big or it's on the we as a whole. Like we have standard of orientation. This preset is crazy. Whoa. Property. Font is set to 24. This to here. Yeah, really. But value, I don't need to see the value of the SWDIO, SWK too big. Goes to 24. Header, they have the drawing already. I'm gonna draw my own. It should be like this is way plus sign, and this one is minus. They got user IO. Mm, okay, on the top layer is right. Let's move to bottom layer. You got this biggie font to be reduced down to smaller size. So this, no. C5, C6, C4, C4. This thing is really big. C5. Okay, mostly. Let me go back to here and gonna add the open source hardware icon, this logo. That is in the top right now. Standard. Okay, so move this thing to the back and then move. Perfect. So before I'm gonna do the ground plane, let's take a look here. Let's see what we have got. Open source hardware. Outside. What is that? Is it that thing? Wait, what is this? Side. VFD32 half. This one is button name. Font is vector. I think there's still have a space left here. And gonna draw my copy this one. Name still not be button there. And this keyboard. Me, of course. So this was font size is 24. We are done. Put the board back, make sure that I save. A lot of this seem to be broken. This one is quite nice here. Since this thing is get in the way of my controller, I need to move that capacity. Hmm, there is this one. This is still weird, but we can move this a little. think you can move this part. It's broken here. Okay, the font look nice. We have the visual hack. I need to move this one. It's nice, 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 nice. Okay, so there is thing that I need to move this one. Last check before. Okay, I think this is good enough. Next thing to do is something called ground plane, but it's called redness. So I need to draw the polygon. Hello. So first I select the top layer and just draw like the draw like around parameter of the board perimeter perimeter and just assign GND like this and then press this button redness. But before that we're gonna do with the bottom layer of the board as well as the top layer we signal of the GND and press this redness. You're gonna see something like this and make top button pick at the board right here. Okay, the period is updated. It's gonna be something looks like this. You see this ground plane around this. Really nice. I'm gonna mark the header pin too so it can run more. That. Totally forgot to do that, but it's really important thing to do. Draw a circle, draw on the top layer like that. Oops. Okay, yep. Yep. Oh, live update is working. The clearance tolerance of the components look nice, but side nice. This here. Okay, so next thing I'm gonna do, I'm gonna upload this board. Still running, almost 2 hours. I'm gonna upload this board to the OSHPark real quick. No, this has personal stuff going on here. So after I upload this board to OSHPark, I'm gonna go to sleep real quick because it's midnight right. And all of the thing I'm gonna upload like the schematic and the code. I'm gonna create my new GitHub repository for the VFD32 and all the. I'm gonna put the code right there and as well as in the description below. So again, guys, stay tuned for the next video. If I have a chance to build this one, processing real quick. Let's see how much is it. How much it cost. sometimes it's take quite a long processing. Its cost board cost 3.15 cents. $3.15. 1.5 cents. VFDHack32 other. No. I feel like I do some typo of the word daughter. DBDAUGTS. Okay. Okay. English. I think I can close. Yes. Save this done. Save and close. Motherboard for preview. VFD. VFD Fat 32 project. I'm gonna update like more GitHub info thingies and stuff later. Click on continue. Port top, port button, drill, seal screen, button sort mask, button seal screen, solder mask. This is look okay, this look fine. The mask layer, layer look just fine. Okay, great. So I'm gonna save it first. I'm not gonna order this thing yet. Since I have a secret project running, I'm gonna give you some clue. It is a Flex Watch project that this time is not e-paper like this one. Let me switch the camera. Not e-paper like this one. The thing is kind of dead now. I'm not sure that I killed it or not, but anyway, next project will probably along with this or after this or before this is Flex Watch, but is it the second generation? And I will tell you that it is something really if I to tell you it is something flexible and yeah, it's obviously it's flexible because this is a flex watch. It is something that couple smartphone uh, manufacturers have done, like Samsung, like uh, we have Samsung and we have a Motorola. Also, there is a tablet PC made by Lenovo. That one is a little bit weird. And I think I want you to guess what is that because this thing is really cool. It's a flexible display, but it is not an e-paper. It is something else. And I hope that I will show you guys in my next video. So thank you guys for watching this video. I hope this 2 hours is maybe 1 hour-ish after some video edit will teach you something. So again guys, thanks for watching this video. Hope you like it. share and subscribe this video would be appreciated for me. And thanks for watching. See you again next time. Bye bye.